PPT audio different geometrical shapes, how to find the x bar, y bar using the equations, and we learned for various geometric shapes like rectangle, circle, sector, and other, and we found four other geometrical shapes, the centroids. So now we are going to discuss on the centroid of composite areas. So we have multiple geometrical figures coming in a single shape in a way. So like this is like a composite area where you have multiple rectangular individual geometrical figures. So till now we have studied only to find the centroid of an individual rectangle, say rectangle 1 or rectangle 2 or 3. So now we are going to find the centroid of this total assembly. So coming to that, the composite areas can be divided into a number of areas like a rectangle, triangle, semicircle, for which areas and locations of centroids of each area are known. So in a composite area, there can be combination of rectangle, triangle, circle, etc. We know the individual centroids of individual shapes. So we have to properly arrange it, properly uh, arrange it to find the centroid of the composite area. So the equation is x bar is equal to integral x into a by integral a is equal to a1 into x1 plus a2 into x2 up to this by a1 plus a2. It is like your CGPA calculation for the university examinations. So the a1 is the area of the first shape into x1 is the corresponding centroid of first figure or first shape plus a2 second area, here it goes, divided by total area. Similarly, y bar is equal to integral y into a by a, same thing, a1 into y1 plus a2 into y2 divided by total area. So we will see a problem to make it clear. So we are supposed to find the centroid of the area shown in figure. So this is the area, and actually these 1, 2, 3 won't be given in the question paper. We are given only this composite area. So when we see this composite area, the first thing which comes to our mind is that this can be split into different rectangular shapes. Say like this, you can split up. You can split maybe at this point, this point. Okay, or also you can split like this also. That's up to you. It's always good to split in a complete rectangle so that the all the dimensions can be taken from this left edge, because we know correctly the centroid from this left edge. So this is the right way of splitting the composite area into individual geometrical figures. So this is given. So total like the depth is 24 and the length here 14 centimeter. 2 centimeter is the thickness all over the composite area. 8 centimeters is the top width. So these are known to you. Now we can use the previous equation. So here it's divided total composite area into 1, 2, 3, where 1 is actually the area of the first rectangle, that is 14 into 2. Here it's there 40 into 2, 28. 82 will be actually 20 into 2, because 24 is the total depth, thickness 2 minus from top, also from bottom. So 24 minus 4 is 20 into 2 is the thickness of the composite, this rectangle, 40. A3 is equal to, we have the full rectangle here, 8 into 2, 16 centimeter square. So these are the calculated values A1, A2, A3. Now to find the x bar, we should know the x1, x2, x3 of individual rectangle. So x1 is equal to, x1 means the first area. So this one, we know that from the left edge, the x bar is a distance of like say width by 2. So total width is 14 centimeter by 2, 7 centimeter. Similarly, x2, rectangle 2, from the left this vertical line, you know that it is a distance of half the width. So 2 divided by 2, that is 1 centimeter is the location of centroid of the second rectangle. X3 similarly total is 8 divided by 2, 4 centimeters. So now we know a1, a2, a3, x1, x2, x3. So a1 into x1 plus a2 into x3, s2 plus a3 into x3 all divided by sum of areas will give you the value. So here in this problem, in this PPT, they have found y1 also before finding s bar and y bar. So let's see the y1. Y1 should be measured from the base. So I am drawing. So this will be the base, the straight line joining the bottom edge. So y1 is this rectangle. Y1 is actually 1 centimeter. So total depth of this individual rectangle is 2 centimeter. So 1, okay. Y2 means y2 is for this one. So when you measure the y2, you should add this length or this height also. So it should be like 2. 2 is this thickness plus total depth is 20. 20 by 2, 12 centimeter. And for y3, you have to start from this length. So 2 plus 20 is already there, as we are measuring the centroid from the baseline, plus 2 by 2. 2 is the thickness by 2, 23 centimeter. So this is clear. And we have x bar is equal to the equation a1 x1 plus a2 x2 plus a3 x3 divided by total area. Similarly y bar. So we got it as 3.57 and 10.43. So when you see these values, approximately like 4 centimeter and 10 centimeter. Coming to the previous figure, so the x bar is actually 4 centimeters. Say maybe at this point, at this value, and the other one is 10.43. The total is 24, so maybe around this. So you can have a guess at where this centroid will be there. So it will be more near to the area concentrated. So you know that the 2 is on the left side, 1 is on the bottom, 1 is having more area. So it will be, the centroid will be more near to the rectangle 1 and 2. It's a guess for checking your answers. Yeah. Coming to the next one, another composite area. So this comprises of a semicircle, a rectangle, and a triangle. So as I told, the in the question paper, the 1, 2, and 3, this division won't be given to you. It will be given only a shape. That means only this perimeter or this outer boundary, and you are supposed to divide the composite area into different multiple individual geometrical figures. So semicircle area, sorry, the radius is 2 centimeter, rectangle 6 centimeter is the width length, and the triangle base length is 3 centimeter. So in this figure shown, divided into 1, 2, and 3. So coming to the x bar, x bar, we know the equation a1 x1 plus a2 x2 plus a3 x3 divided by a1 plus a2 plus a3. So it's very easy to remember. X bar means it should be x1 x2 x3, then a1 a2 a3 is common for even for x bar and the y bar. Okay, yeah. So a1, this semicircle, you know that pi r square is the total area of a circle by 2 is the area of the semicircle, 6.28. A2 is rectangle, 6 into the depth is actually 4 because 2 is the diameter, right? So 2 is radius, 4 is diameter. So 6 into 4, 24. For A3, half into 3 is the base width and height is 4. So you got 6 centimeters square. Now little care has to be taken for finding the x1, x2 and x3. So see that the central, like the coordinate axis is located at this point. X bar, sorry, x y coordinate is on the left extreme end and passing through the bottom of the geometrical figure. So all the measurements should be taken from this coordinates y and the x. Let's see that. X1 means the horizontal, right? So x1 is equal to r minus 4r by 3 pi. R minus 4r by 3 pi. Why there is a minus? So we know that the centroid should be measured, or centroid is measured from the bottom line of the semicircle. Like from this dotted lines, we are measuring the 4r by 3 pi. So we need the x1 from the extreme left axis. So r is the total radius minus 4r by 3 pi will be the x1 bar distance, right? So you got it as 1.15. And for x2, for this rectangle, individual rectangle, you know that the centroid will be at the Paka center portion. So x2 is equal to 2 plus this 2 is the radius of this semicircle. So actually you are measuring from maybe this point to this point. So up to this new line, it is 2 centimeter. This is 2, and this is actually total value is 6. So 6 by 2 is 3 here. So 2 plus 3, 5 centimeter for the x2. X3 means you have to start from covering both the semicircle and the rectangle. So it should start from here up to this point. So first 2 is the radius of the semicircle. This 6 is the total length of the rectangle, and then we know that for the rectangle the value is b h by 3 as well as b by 3, h by 3 for the y bar and b by 3 for the x bar. So total base width is 3 centimeter. So b by 3, that is 1 by third of 3 is 9 centimeter. So we got the x1, x2 and x3. Similarly, we can find the y1, y2 and y3. Yeah. So how to find this? So the good thing is that y1, y2 and y3 can be easily solved, as we know that all the values are taken from the baseline. We know for the semicircle, the centroid will be at this point, at covering maybe like passing through the centroid to the G2. So y1 is 2 centimeter, y2 is for rectangle also passing through the G2, and the y3 is 1.33. It is actually total height is 4 centimeter, right? Yeah, radius is 2, diameter is 4. So the triangular height is 4 centimeter. So 4 divided by 3, h by 3 will be the y3 value. So once you found all these a1, a2, a3, x1, x2, x3, y1, y2, y3, you can directly substitute in the equation to find the x bar and the y bar. Yeah. Now something more complex figure is coming for this problem. By seeing this figure, you should actually should think that, or you should find out that this section, this complex section, can be divided into a rectangle. Say a rectangle, sorry, a triangle passing through this point, as well as an arc. So here actually they are splitting the total circle, total shape into the triangle area as well as the sector of a circle, right? So so by this individual sections we can find the centroid for the composite area. So what is given here is the 10 is the total say arc length, and here given a 60-degree angle is the total angle till this point. Okay, this is actually I made a mistake in drawing this one, so it's passed through this point. Like this figure will be clear for you. So you can find the necessary values, the 10 sine 60 will be the total height, 10 cos 60 will be the base width of the triangle. Then as this is 60-degree, this also will be 60-degree on alternate angle grounds. And then G2, you know that, should know that G2 is measured from this 90-degree corner. Okay, G2 is measured from the 90-degree corner, and we have the G1 measured from the centroid portion. So now we can club all these values and find the centroid. So the split up, the A1 is here they taken A1 as this arc. Okay, so pi square into 60 by 360. So pi square is the area of circle, and into 60 by 360 means we know the total angle is 360. So 60 is the sector. So this ratio will give you the corresponding area of this sector. They found it at 5235.99 mm square. A2 directly the triangle, so half BH. We found 10 sin 60 as the height and 10 cos 60 as the width. So A1, A2 is found out, and OG1. OG1 is the centroid of this arc, this sector from the centroid. So we know that the from this point the value is 4r into sine alpha by 2. So I have given this value previously, that yeah. So centroid of sector of circle is actually x bar is equal to 4r into sine alpha by 2 by 3 alpha. So that equation is applied here to find the OG1. So we have the OG1 as 4r into sine alpha by 2 by 3 alpha. So alpha is 60-degree. So you can apply those values and find that OG1 is equal to 63.66. So this is actually along this inclined direction. We want to find the x1 as well as the y1 of this OG1 component. So x1 is equal to OG1 cos alpha by 2 will give you the x bar component, and y1 is equal to OG1 sine alpha by 2 as the y1 component. And similarly we have the x2 and y2. So these are for the triangular areas. For this triangular area, we know that the x2 is the horizontal one. The all the b by 3 and h by 3 is measured from the this point where I am putting my cursor now. So directly it is with respect to the left axis. So the x2 is actually one third of this base. One third of is actually 10 cos 60 will be the centroid of value of x2, and y2 actually has to be found from base. uh, Let me take, yeah, we know that the centroid is at a distance of h by 3 from this base, h by 3, but our coordinate is actually this, right? This is our coordinate, so we have to measure from this baseline to this point, so that 100 sorry, it's actually 10 sine 60 is the total depth of the total height of the triangle minus one third of 100 sine 60 will give you exactly this value from G2 to the baseline. Say from this point to the this point. So that is required because as our axis is actually x and y. So we found the x2, y2 and all the parameters. Then you can directly find the x bar and y bar. And yeah, you can directly find the x bar and y bar. The next problem is actually it's given a twisted way, which makes us to think on the problem. So the question is a semicircle area of 20 centimeter dia. So you can see that I will move the cursor. So this is the boundary of the geometrical figure, and a semicircle area of 20 centimeter was removed from a thin plate of 50 by 50 centimeter. So from here to here 50 centimeter, from here to here 50 centimeter. From this plate dimension, a 20 centimeter radius semicircle area is removed. It is desired to maintain the centroid of the plate at the original point. That is, for the rectangular case, you know that the centroid is exactly at the middle. That is 25 from left and 25 from bottom. So as we have removed the semicircular portion from this rectangle, definitely the centroid will shift to the right. As we are removing the material from here, centroid will shift from right, and it will be on the horizontal axis. That is, the vertical won't change. I think you know that because the semicircle is exactly cut from the center portion. So the y bar value will be same. Only the x bar will be shifted to right as we have removed the material from the left side. It's only initial guess. Yeah, and it is designed to maintain the centroid of the plate at the original point. So we need to bring back the centroid to maybe some this point to this point. For that, determine the width of the material shown shaded on the left to be removed to achieve this. So, please note that when we are removing a semicircle, the centroid will shift to the right. So if I remove some portion from the right, then obviously the centroid will shift towards the left, and at some point it may reach at the previous centroid. So we want to find this region to be cut so that the centroid will be kept constant as previous. So that's a challenging question. So in this case, we are dividing the total area into three. G1 is the total rectangle, and the G2 is the centroid of that individual rectangle which has to be removed, and G3 is the centroid of the semicircular area. So we have 50 centimeter total depth and 50 centimeter total width. Then yeah. So since solution, since the plate is symmetrical about x-axis, so you know that pointer and so the x-axis is actually yeah, this horizontal axis. Y bar is equal to 50. That is exactly at the center y bar. So there is no doubt. Y bar is 25 centimeter. Now we have x bar is equal to a1 into x1. It is the total rectangular area. Total rectangular area. Then as we are deducting two material, that is semicircular, we are actually deducting from the total rectangle, and we are going to remove the third area also, right? So both the things should come in the minus. This is the main change in this problem. The deduction should be addressed by a negative sign. Okay. Similarly on the area. So minus 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 minus. Now we can directly put the required values and solve the equation. So the total area of the rectangle is 50 into 50, is clearly given, 50 into 50 total area. A2 is actually, we know the height of the rectangle, we don't know the width, B to be removed. So 50 into B. Let it be like that, 50 into B. A3, directly we know the radius of the semicircle, so 157 centimeter square. X1 is equal to 50 by 2. Uh, X1 is actually for the total rectangle at the exact center. For this rectangle, exactly at center, that is 50 by 2 is the X1 value. X2 is what? X2 is this, the rectangle to be removed, right? So we know that for this rectangle, the centroid will be at correctly at the b by 2 point, at the correctly at the middle. So x2 is actually 50 minus b by 2. 50 minus means, because we are taking the coordinate axis from left, right? This will be the one coordinate and this will be the other coordinate. So 50 minus b by 2 is the centroidal axis for x2, and S3 directly connect, because we know that the y is here and the x is here. So directly 4r by 3 pi is the value for x3, 4.24. In now our condition is that x bar is equal to x1. So x bar is the new centroid, should be equal to x1. So we know that the centroid of this rectangle is at the centroid of, or the center of the rectangle, right? So to keep the both the same, the value should be 25. 25 is the middle portion or the centroid portion, previous to, like, before we cut, before we made a semicircular cut as well as a rectangular cut. So we want to keep the centroid at the 25th centimeter. That's why x bar is equal to x1 is equal to 25 centimeter is a required condition. Now we can apply the values. So now the left hand side is known to you, 25. In previous problems we found this 25, or we found x bar. Now this is known to you. When you apply into the equations, only thing which you don't know is the b value. But as there is only one unknown, you can simplify the equation to find the value of b as 2.76. So the thing is that when you should remove approximately 2.76 width rectangle to make the centroid same as before. So that's the takeaway from this problem. So the important thing is that the minus signs for the deducted areas. Now we have two more problems. Locate the centroid of the shaded area. So actually we have to find the centroid of this shaded area. So when you see that this can be a combination of rectangle, then a arc, all things are there in this geometrical figure. So we have given the total radius of this arc as 9 centimeter, and this is 9 centimeter. Let's see how we can do this. So we can divide this total geometrical or composite shape into a rectangle 1, and 2 is this portion, and we have the 3 as this portion. So we can deduct the 1 from 3, so that from total area we can deduct the 1 from 3 to find the shaded areas. So the A1 is actually the rectangle, so directly given the value. So when you are turning to this point, you will get the width of rectangle as 9 as well as the length of rectangle as 9. So 9 and 9 is 81 centimeter is the total size of this rectangle. A2 is equal to A3. So A2 means this one, this non-shaded portion, pi square by 4, and this A3. So both having the same radius, right? So for this one also we have the A3 is pi square by 4, 63.62. Now x1 is for rectangle at the center of the rectangle 9 by 2. For x2 is this one, right? It is 9 plus, you know that x is starting from this point. This is the x and this is the y. So 9 plus 4r by 3 pi, 12.82. X3 directly from the base, so it is actually 4r by 3 pi, and y bar is also a rectangle at the pure center. Y2 all from the base, y2 is from the base, so directly 4r by 3 pi. Y3, the 4r by 3 pi is from this point, right? So we have subtract r minus 4r by 3 pi, 5.18 from this point. From here to here it is 5.18. Now we can apply the values. So note that the x bar in this one term will come minus. That is 1 is rectangle plus this sector minus 3 minus a3 into x3, also denominator minus a3. So we'll give you the x bar and y bar. So I will stop for today. So I already shared the PPT with you. Once you are clear with the previous problems, you can solve for the remaining ones. That is, this also you can solve by your own. Problem number 6. This is only an arrangement, as is having more individual sections. They have just tabulated it 1, 2, 3, 4, 5, and the minus is for the areas to be deducted. And you can try even this one also, centroid of the lowered area by integration. Same principle, only some rearrangements are required. You can try this one and you can try this one in an integration point of view. And in next class, we'll start with the theorem of Pappus and Gildenus.